A function f is defined by f of x equals a over x plus b over x squared, where a and b are constants. It's given that f prime of 1 equals 2 and f double prime of minus 1 equals minus 2. What is the value of a plus b? So immediately we should think to use the information they've provided. So if I differentiate this, we've got a to the x minus 1, so then we'll get a power of minus 1. And so we'll get minus a, and then because we're dividing by 1 squared, it will just be minus a. And then the b to the x to the minus 2, so times x to the minus 2, we'll get minus 2. And then it will be over 1 cubed. So we've got this is equal to 2. Now, bearing in mind that we want to differentiate it again, we just need to keep track of the powers that we've had. So a would have differentiated to minus a over x squared, and then this will differentiate to 2a over x cubed. This will be over minus 1 cubed, so this will be minus 2a. Now b would have differentiated to minus 2b over x cubed, and then plus 6b over x to the 4. So that's plus 6b over minus 1 to the 4, which is just plus 1. And this is equal to minus 2. So from this, we have that a plus 2b equals minus 2. And then we also have that a minus 3b equals plus 1. So I've just divided the second term by 2 and then multiplied by minus 1. So now if we take one away from the other, we've got that 5b equals minus 3. So b equals minus 3/5. And then a plus b is equal to minus 2 minus b. So I don't actually need to find what a is. I could just rearrange the top equation, a plus 2b is minus 2. That's minus 2 minus minus 3/5. So that's minus 2 plus 3/5. So that's minus 10 over 5 plus 3 over 5. That's minus 7 over 5. Now, some of you might have thought, okay, why don't I just find a? And you could have done that. I'm pretty sure it'd still be as quick. But something that I want to encourage you for this kind of test is sometimes you don't have to find each term individually. Sometimes if you see an expression like p times q or p plus q or p divided by q, in some questions there's a way to get the composite, so the product or the quotient of these things or the sum of them together without actually having to find each term individually. And so I encourage you to look for that as your first port of call, but sometimes it will involve you actually needing to find each term individually. But just as a recommendation, again, this is based off things that I've seen throughout my studies and while I was at Cambridge. Whenever we did problem sheets, you'd want to get terms together because they'd ask a question as something would naturally crop up that depend on those two terms. So it might be that a plus b naturally cropped up from when you were solving for something. And a common error that, well, not error, but a common thing that students tend to do is, let's say you got something like r squared, or you need to find the area of a circle, which is pi r squared. Sometimes what students will do is they'll try to solve for r, and then they'll get an r squared, and then they'll square root it, and then they might square it again when you had it perfectly packaged as r squared from your solution. So if one of your solutions involves the thing that you're trying to identify, then just use it. Don't try and find each thing individually because they're not asking for each thing individually. They're asking for the thing together. So if this can be done, try to do it. If not, go ahead and try to solve them individually. You won't always know, so it's good to just be comfortable with either path.